So, welcome to module 8.3, where we are going to talk about the Jack syntax of Jack. So, when you are studying C, you would have looked at syntax and semantics of the C programming language. Similarly, now we are looking at the syntax of the Jack programming language, and that will be part of this particular exercise. As mentioned earlier, Jack is an object oriented programming language. Now, we will try and basically explain Jack through another example, what we call as fractions, right. So, there are so fraction is nothing but has a numerator and a denominator, and always we will write to have a reduced fraction. For example, I will not if you give 2 by 10, I would like to represent it as 1 by 5. So 1 by 5 is the reduced form of 2 by 10, right. So how do we, so I want to represent several fractions. So now we will have one template for a fraction, which you will instantiate many number of times to create several fractions, right. Now this is the fraction API. The API stands for Application Programmer Interface. Somebody wants to use fraction, how can they use it? This class that I am describing here tells the application programmer how he can use it. That is why this class is also called as an Application Programmer Interface, right. Now, first class fraction, okay. We start with a braces. This is a syntax. Now, the first thing is whenever I describe a class, I should describe a constructor function. A constructor function is one which will construct that class. Every time I am instantiating that class to make an object, the constructor function will execute first and it will create that object for you. The constructor function essentially, so if I have 10 fractions, I need 10 different memory locations to store the fraction. The constructor function, one of the prime objective of the constructor function is to create some memory for this and basically create a memory for it and then store the values inside it, right. So there will be the moment I say class fraction, there will be a constructor for this class fraction, as you see here. I am moving the mouse on top of it, and then there will be a new. So always every class XXX will have constructor XXX followed by new, okay. And this constructor function needs two integers, int x and int y, one for the numerator and another for the denominator, okay, right. So there is a constructor function. Then what are the other functions we need for the application programmer? So if I have a fraction, I would like to know what is the numerator, I would like to know what is the denominator of the fraction. So there are two methods defined inside which will allow the application programmer to go and find the numerator and the denominator of the fraction that he or she has defined. So there is a method called getNumerator, which will return an integer which is the numerator. There is method called getDenominator, which will return an integer called the denominator, which is the denominator. Then I will have another method which is basically which will return a fraction, another method called plus, which will take as input some other fraction and add it to the current fraction. It will take so there is a fraction x. If I say plus is a method sorry, which will take another fraction and add it to the current fraction, okay. And then when I create a fraction, when I create an object fraction, sometime after that I may not need it, so I have to throw it off. So there is always, every class will have a dispose function which will dispose this fraction. Always it will have this dispose function. like how I have a new which is equivalent to creating memory and storing for that particular object, right. So, whenever I create an object from a class, I create a memory and store it. So, that is like malloc, and whenever I want to dispose, this is like free, right. So, malloc, if you malloc a particular pointer, giving it lot of space, then you go and free that pointer once you do not use it. So, this dispose is equivalent to free, and of course, I could have a print statement for this fraction, right. So, example of fractions are 2 by 3, 1 by 5, 2 by 7, 3 by 4, 1 by 2, 8 by 9, 5 by 6, 2 by 19, and these are all different varieties of fractions that you see. But this fraction implies that it is a reduced fraction. So, I will not have 2 by 10, rather I will have 1 by 5, right, for example. So, this is the API for fraction. So, how will main basically, so how does any application programmer use this fraction? So, he creates a class called main, inside that a function called main, small main. So, main. So, then this is where fraction, because we have a class A, B, C. So, A, B and C are objects of the type fraction, of the class fraction. So, I have created 3 objects of the class fraction here. Now, I say let A equal to fraction dot new 2 comma 3, right. A equal to fraction dot new will construct that fraction given. So, A is of the type fraction, and what is that fraction? Now, I am initializing A to fraction dot new 2 comma 3. So, A will be 2 by 3. Similarly, I am initializing let B equal to fraction dot new 1 comma 5. So, B will be 1 by 5. Now, so A is a fraction, B is another fraction. So, what is there inside A? There is a numerator and denominator 2 comma 3 here, and then for A I have all these methods like get numerator, get denominator, plus dispose, print. Similarly, for B also I have all these. So, for every fraction that I have defined, so I have the numerator, denominator. In addition to this, I do have all these application programming interface, namely constructor, get numerator, etc. Now, C is equal to A dot plus. So, I am using fraction A, and for fraction A there is a plus, right. So, that is why I say A dot plus, right, and that will take another fraction, other fraction as input, that is B. So, A dot plus B basically takes A as in the A fraction there is a method plus to which I am inputting B, and this will give me C. This is expected to give me A plus B, right, and that will be C, because that particular plus function returns a fraction, that is why I say C. Now, this C I print this C, so C dot print and I return. So, this is how the application programmer actually uses this fraction, using the different routines, methods that are given as part of your fraction class. Now, how do we populate this class fraction? So, inside this class fraction, I have 2 fields. So, field is a keyword and both of them are integers. One is a numerator, another is the denominator, right. So, these are all variables inside, and so method int get numerator. So, now these 2 are the fields. Now, I have to see the accessor functions. Accessor means which will access the different fields here. Method int get numerator will return the numerator for me. Method int get denominator will return the denominator for me, right. So, this is how I get numerator, get denominator, okay, right. right. So, I can say so this I can define another class flu, whatever main or whatever, and inside there is I am declaring a fraction called x variable. Let x is equal to fraction dot new 5 comma 17. So, this will give me 5 comma 17. So, 5 by 17. So, the moment I say fraction dot new, this will the numerator will become 5 and 17 will become the denominator for x. So, x is a type of this class fraction in which its numerator is 5 and denominator is 17. Now, if I want to access the numerator, I can't say x dot numerator, this fellow will not allow us. So, any field I want to access, I have to go through these methods, right. So, I can't directly access x dot numerator like in the struct case. So, if I want to in struct, I could have put, if the struct fraction into numerator, I say x dot numerator, but in this case I can't do this. So, I have to say do output dot println x dot get numerator. X is a object of this fraction, associated with x would be a get numerator which will give x's numerator, and the associated with x there will be a get denominator which will give you the denominator of x. Similarly, if I had declared another fraction y and I say get numerator, it will give me the denominator of y, y dot get denominator, y dot get numerator, it will give me a numerator of y, right. So, x dot get numerator is correct, x dot numerator I can't directly access. So, this is basically the object orientation and what we call as the data hiding, or so any data about the object that I have instantiated I can only get through the accessor function, I cannot read it directly, right. So, we have seen so that different accessor function we have finished off get numerator, get denominator. Now, we have to see what do you mean by constructor function, fraction new int x comma int y. So, I gave 5 and 17 as input. What will do? It will make let numerator equal to 5, let denominator is equal to 7. So, that x and y gets to that particular field. So, when I create a new fraction, when a new object is created, the numerator of that will become x and denominator y. But then so we don't say, suppose I give 5 comma 10, I don't want it to be 5 by 10, I want it to be actually 1 by 2. So we do reduce. What is this reduce? Do reduce. So, reduce is a function inside this fraction. So, what will reduce do? It will find the greatest common divisor between the numerator and the denominator, and it will divide it by that greatest common divisor, so that after that division the greatest common divisor between the numerator and denominator will be 1, and that is the reduced fraction. And for that we use what we call as the Euclid's algorithm. Okay. So, void reduce will do g equal to fraction dot GCD, greatest common divisor of numerator comma denominator, right. And if g is greater than 1, let numerator equal to numerator by g, let denominator equal to denominator by g, and it will return. Okay. So, essentially this will adjust the numerator and denominator to become equivalent. So, how do you compute the GCD? For computing that, so this fraction, so it uses a function. See, void is a method, reduce is a method that uses a function called GCD. So, GCD is a function and it takes in two inputs a b and it applies the Euclid's algorithm. I want you to go and use I hope all of you know Euclid's algorithm for finding the greatest common divisor. If you don't know, just go to Google and find out. It basically finds the remainder of a by b and it makes a equal to b and b equal to r, and it keeps on repeating. So, that is the Euclid's algorithm. So, this will return the GCD. Okay. Now, right, and this is how it works. So, now after I get back, after I do the reduction, your numerator and the denominator will be set as with the GCD as 1. So, if I have 2 by 10, it will become 1 by 5 and etc. And then I say return this. What do you mean by this? This actually in object orientation refers to the current object. So, if I am in an object, I am modifying an object and I want to return to the calling function. So, essentially I say return this object. So, this, so now you can slowly correlate. We have been using this and that as part of your arg3 and arg4 etc. in your symbol table, in your VM etc. So, this and this will be used for the quote unquote this will be used for this purpose, as you see here. So, this will return back the same object here. So, always a subroutine must terminate with a return command, and so this is what is happening here, and this is how this goes, right. So, the last thing that we need to see in the fraction, as we have seen, is plus, right. So, this we have seen a plus here. Basically the so class fraction, so we have put all the other things here. So, method fraction plus fraction other, some other fraction is input here and we have to sum it up. So, where int sum numerators, let sum numerator equal to the numerator of the current fraction into the denominator of the other fraction plus the numerator of the other fraction, that you get it by using other dot get numerator into denominator of the current fraction. If I want to do a by b plus c by d, it is ad plus bc divided by bd, right. So, the numerator sum is current numerator into other fellow's denominator plus other fellow's numerator into current fellow's denominator, and return fraction dot new, create another fraction which is some numerators whatever comma denominator into others denominator. So, this will be, so this fraction dot new in turn will again call reduce, and it will give you a reduced version of this, and this is how this whole thing works. So, now we see that there were methods and there were functions. What is the difference between method and functions? Methods are those which can be used by the external world. Functions are those which cannot be used by the external world. For example, somebody can say do say suppose I declare fraction a. So, where fraction a, I can say a dot get denominator, a dot get numerator, a dot plus, a dot dispose, a dot print, etc. But I can't say a dot gcd, right, because gcd is a function inside this. I can't say a dot gcd, I can say a dot reduce, I can say a dot new, I can still say a dot plus, but I can't say a dot gcd because it is a function inside this. Now, this is how I can this is a fraction. Similarly, method void print, do output dot print int numerator, do output dot print string slash, then output dot print in denominator. So, if I give so print a fraction a dot print, it will print the denominator divided by numerator this slash sign divided by denominator. So, this is how it prints. So, this is the total overall how a fraction is being built. Okay. And very importantly, Jack has no garbage collection. So, we are responsible for actually releasing whatever we do not need. So, if I use a fraction and I do not need the fraction, the first point where I do not need something, whether there is garbage collection by the programming language or not, one programming practice that we need to follow rigorously is whenever we do not need something, immediately free it out, and that is very, very important. So, here when we use this method void dispose, so what it does, do memory dot dealloc this is the current object. So, I dealloc this. So, memory dot dealloc is equivalent to your free command, and who provides you the code for this memory dot dealloc? The OS routine actually provides this command, and then you return back, right. So, best practice is every class that has a constructor should also feature a dispose method, and this is true even when your operating system does support garbage collection. Garbage is something like you use malloc for C people. If you have used malloc and you never used free, then that will be a garbage. So, C actually the operating system actually does some garbage collection, but in this case we don't do garbage collection. So it is a responsibility for us to free, and in general a good programming practice is always to free off the memory whenever you don't need it, right. That is very, very important. Okay. So this is how the whole thing works. Right. There is a two view, there is a client's view and this is a system view. So whenever we start, this is something that we need to understand very quickly and very nicely. So when the client code is executing, you say they have described three variables, namely a, b, c as fraction. Now we say let a equal to fraction dot new 2 comma 3, let b equal to fraction dot new 1 comma 5. So from the client's point of view, there is a memory address called a, which will point to two memory locations storing 2 and 3. There is another b which will point to two memory locations storing 1 and 5. One is for the numerator and another is for the denominator. This is the client's view. But in real system, what happens is in the stack, whenever this class is encountered, let a and b are encountered, there is an address that is created on the heap. That is 15,087 and 4112, for example. And you go to 15,087, there are two locations that are created along with 15,087, because this a has two integers numerator, and 87 and 88 you store 2 and 3 for the numerator. Similarly for b, which is stored at 4112, 4112 and 4113 stores 1 and 5, 1 by 5, right. Right. And then so the moment we say fraction the moment the compiler encounters a, b and c, immediately for a, so in this case a and b for example to start with, so the a and b are allocated a space in the stack and nothing is initialized here. So these things will not be initialized. The moment it sees a, b, for a and b in the stack there are two spaces allocated. Then when it executes let a equal to fraction dot new of 2 comma 3, at that point it will go and find out in the heap where there are two locations, and that address it will put here 15,087, and if you go to 15,087 you will find the fields of the current fraction, namely 2 and the numerator and denominator. Similarly, the moment we execute let b equal to fraction dot new of 1 comma 5, now b is already assigned this location on the stack, whatever be this. Inside that location we store 4112, and in 4112 is given by the operating system. It says okay, take it, and there you go and store in 4112 1 and 5. Right. So when I mean by deallocating this memory, when I go here I want deallocate. So in the heap 4112, 4113, 15,087, 15,088 are both now non-empty, they are not free. The moment I say deallocate the a, now it will go there, it will find out okay 15,087, and this is a has two objects inside that, so it will go and free out 15,087, 15,088. Similarly 4112 and 4113, this will be freed out. So this is basically how the fraction works. So this is the actual implementation. This is the abstraction of a and b, and this is the implementation of a and b, right. Right. Now we will see the last one example here, which is the list processing. So list is nothing but an element of this form, right. So you would have seen linked list as a part of your C programming, but it is a self-referential structure. Self-referential in the sense it will store one element, as you see here it will store one element, in this case 2, and it will point to another list of the same type. which will in turn store 3, and it will point to another list of the same type which will store 5, and this is null. And there is always a header to the list. So, this is called a linked list, and there is a header to the list which we call as V, which points to the first element. So, initially the this is a null, initially it is null, then we add 5, it became 5 comma null, then we added 3 and the front of the list, it became 3 comma 5 comma null, now 2 comma 3 comma 5 comma null. So, a list is a data structure in which it stores an element and it points to a similar structure. So, 3 comma 5 is a list, 5 is a list, null is a list. If you take here, we will just look at this figure, null is the list. Now, 5 comma null is another list, 3 comma 5 comma null is another list, 2 comma 3 comma 5 comma null is another list, right. So, a list stores an every element of the list stores an every entry of the list stores an element and a pointer to a list of the same type. So, 2, this first location here stores the element 2 and points to another list of the same type, which in turn stores 3 comma 5 etc. Right. So, this is the understanding of the list. List is a self-referential structure, it refers to another list as a part of its definition. So, how do you define? So, this is again API for this list. So, we can construct a list new which has an initial element and the next element would be null. We can print a list, we can dispose a list. Okay. So, these are all the APIs. So, how do you use main? Main again a class main with the component main. Now, where list V. So, V is of the type list, V equal to list dot new 5 comma null. Okay. So, this always. So, V equal to list dot new 3 comma V, V equal to list dot new 2 comma V. Right. There are 2 extra parentheses here which may be neglected. Okay. So, first V will be 5 comma null, second it will be 3 comma 5 comma null, the third will make it 2 comma 3 comma 5 comma null, and then there is do V dot print, can print the entire list starting from the beginning, and then do V dot dispose, we need to dispose the list also, and return. So, whenever I do dot new, I have to go and dispose. So, this is how I maintain a list and declare a list, define a list, print a list, dispose a list, etc. Okay. So, how is the list? So, we will now start doing step by step. Class list, field int data, field list next. So, the client code would be where list V, V equal to list dot new 5 comma null, V equal to list dot new 3 comma V, V equal to list dot new 2 comma V, right. So, this is how it goes. So, this is a constructor, list new int car list CDR. So, one will be an integer and another will be the other list, and what will the constructor function do? Let data equal to CAR and next is equal to CDR and return this object. So, the first time where list V, the compiler will create one location on the stack with a junk there allocated to V. The moment I say V list dot new 5 comma null, so this list dot new will be called here. It will create a space for storing the CAR and CDR, and so what it will do, your CAR is 5 and your CDR is null. So, the next is null and it will return this, means return this object, whatever you see here, return this particular object. Okay, it will return this particular object. So, your V gets assigned to this particular object. What do you mean by return this particular? It will return the address to this particular. So v now points to 5 comma null. Now the next statement, v equal to list dot new 3 comma v. So the list dot new will now find 3. This dot new again, it will make that, it will create another data and next, which is different from the previous data and next. It will create another data next, in which the data will be 3 and the next will be v. So next will now point, the original v was pointing to this. So your the next of this will now, the next of this will now point to this. Now since I am making this v is equal to next of 3 comma v, this old v will go, now the new v will point to this 3. So I have created this list now. Now we will see the next step again, this will be right. So this is how the list can be constructed. So this is actually equal to v equal to list dot new 5 comma null. Let v equal to list dot new comma 2 comma list dot new comma 3 comma v. So if I do this, this is equivalent to creating. So this v is 5 comma null. Then I create 3 comma 5 comma null with this list dot new. Then I create 2 comma 3 comma 5 with null for this third list dot. So since a list points to itself, it is called a self-referential structure. Now let us say do v dot print. So what we do, how do you do this v dot print? Where list current, let current equal to this. Okay. So current will start with v, while current is not equal to null, while current equal to null is not equal to null. Do output dot print in current dot get data. Get data will get me the integer for that, and do dot print char 32. 32 will be space, the ASCII equivalent of 32 space, and do current equal to current dot get next. So you start with current as this. This means v. That is where this becomes very useful. This means the current object, and then current as this v. Now while current is not equal to null, you keep repeating print get data of v, that will print, and you print it too. Then it will put a space. Then you say current is equal to, current is this, right? Current and v are same. Current is equal to so this is this. So now current is this. Now while current is not equal to null, current dot next, current is this, current is not equal to null. No, current is pointing to something here. So we just print current dot data. Now current equal to current dot get next. So I go there. Then I print current dot get data followed by blank. Now current equal to current dot next. I print the next data 5 and then go here. Current equal to null, yes, it is null. So I return. Right. So this is how 2 comma 3 comma 5 is answered. Right. The last thing is dispose. Dispose is a very interesting algorithm, and this is a recursive algorithm, as you see. So method void dispose. So again method is used when somebody outside can use it with class. Function is something which is used internally by the class, like GCD in the case is a function. Well, here dispose is a method, or dispose there also in the case of fraction was a method. Now let us see, while next is not equal to null, do next dot dispose. When next is equal to null, and after doing this particular statement, this is the first statement. So this recursively calls dispose. Dispose calls itself, and after you come out of the recursive call, do memory dot allocate this and return and go. Okay, right. Now how do we do this? Now so I have V and I want to dispose this entire thing. So how do you do this? First V dot dispose. So this is this, immediately this means this is pointing to this, while if not next is equal to null, next is equal to null is not true here, okay, because we have V, this dot next is not equal to null. Do next dot dispose. So the moment I say next dot dispose, another function is called. So that will have its own activation record, etc., and that this will be pointing to 3, this one. Now the next of this is not again null, so I will again call next dot dispose, and that this again, now that this will be pointing to 5. So always that this is a keyword which will point to the current object. Now this dot next is actually null. So I come to this part. So I do memory dot dealloc of this. So this memory gets deallocated, and I return to what? The fellow who called me. It was this dot next. This is the fellow who called me. Now I go, and after so where did he call? He called at this point. When I return, I have to go to this point there, right? So here I find do dot memory dealloc of this, and that is going for recycle. And after that I return to the previous call of dispose, in which this was pointing to this, and now I dispose this, right? So the dispose is a function which called another dispose, which in turn call another dispose, and every time I was going to a different list, and every dispose had its own this, right? So that this, so then we disposed the last one, then the next one, then the next one. So we went one full scan from the top of the list to the end of the list, and while returning back we kept disposing them one after another, and we came here. But note that every call had its own this, right? So now that when we implemented the return and call and return functions of the VM, we were storing that this of every calling function, and so that when it returns I go back to this, so this of that particular calling function, and this basically explains you the notion of the keyword this, okay, right. So what did we do so far? We saw examples of building a list, processing a list sequentially, processing a list recursively, disposing a list, and this magic actually works. So when an object is constructed or disposed, the OS is responsible for allocating and reclaiming respectively. The list to processing is implemented by pointer manipulation, as you see here, and the pointer manipulation is done by the code that is generated by the compiler. So you write this code, and the compiler has to compile it into a VM code which will manipulate this pointer. So we are going to see all those things, but as such, as a programming language, this is how we can use it, right. So before we go into the syntax of the Jack language specification, we will now go to the next part of project 9, wherein we will show a couple of more examples before we start looking at the Jack language in more detail. Thank you.